Alrighty guys, let's continue with this inverse trig stuff. As you can see at the top it says please have your trig book open to page 253, and that's because I want you to get used to where do I look to find the correct answer. And in my last video I tried to give you guys a big overview of all the concept behind inverse functions. Because you'll find stuff in the AP Calc packet about inverse, and I wanted to remind you we did a lot of work with it. But I have a couple examples here that are long-winded, but I want you to really get this idea about what makes something invertible. Now, here's what the questions in this section are going to look like. They're going to look just like this over here where it says y equals tan inverse of 1. Well, let's look at what the tangent inverse is based on. So here we go. I wrote this down at the bottom. The tangent, just for tangent, I can do this for any function, but these guys are easiest to see. So the tangent concept, if I look at a tangent graph, first thing I know is if I drew a vertical line anywhere through that graph, I will only hit that function in one location. That means it's a function. Then, if I wanted to draw a horizontal line through it, it would only hit the graph in one location. That means it can be inverted. But here's the thing that you have to know. Tangent doesn't just exist between negative pi halves and pi halves. It goes this way forever. It's going to repeat that pattern forever and ever. It can go this way forever and ever. It's going to repeat that pattern. So to make a function invertible, sometimes what we do is we say, hey, we have to pick just one version of that graph so that it passes the vertical line test and the horizontal line test. And for tangent, if you sketch just one period of that function, it fits nice and pretty between negative pi halves and regular pi halves. So we can then look at this concept. Here's my arrow. We can think of it as two quadrants on our regular XY coordinate system. So it means when you're going to try and answer a question about an inverse function, oh my gosh, leaf blower outside, you're going to only look in quadrant 1 or 4, because that would be where I could draw a reference triangle for tangent, and it would cover all the positive possibilities, that would be quadrant 1, and it could cover all the negative possibilities, that would be quadrant 4. And that's what lines up with the chart, the very last column in the chart on page 253. Now I told you, the concept behind this stuff is there's a lot of involvement, but the actual problems you are going to do are extremely easy. For example, so let's look at the question. It says y equals tangent inverse of 1. So what are you going to do? Well, technically, you're going to take the tangent of both sides, and then the statement says, well, the tangent of some angle y, some angle I don't know, equals, now over here, if I compose these functions, I get 1. So I'm saying to myself, hey, I know what that is talking about. It means if I drew a reference triangle, and since this is a positive 1, I'm going to go into quadrant 1. If I drew a reference triangle, and I said, here is some angle y that I don't know, the opposite over adjacent would give me a tangent of 1. And then I look at that and I go, hey, this looks very familiar. This is like my bow tie thing. And I don't have to do Pythagorean theorem to figure this out, because what is angle y? Well, y would be a 45-degree angle. Now, here's the thing. Be careful in this section of the book. The very first part of the problems, they're going to ask you to write all of your answers using radians. So the answer they want is y equals pi over 4. And then there's another section where in the book it will say use degrees for all your answers. So when they ask you for radians, you give them radians. When they ask you for degrees, you give them degrees. But really, this is how your questions are going to look. And this is why I went over that whole thing with the bow tie. If you get those bow ties stuck in your head, you're just going to be able to rattle off the answers easy. But it's not bad to have a little visual aid to help you. That's just a visual aid. Okay, so tangent. Well, what about cotangent? We haven't graphed these in a while, but they are on your AP Summer packet. You should recognize the graph of these functions. And let's look at cotangent. So I did one for cotangent. So the cotangent concept. Once again, what are the questions in this section going to look like? They're going to look like this. But if I were to graph a regular old cotangent graph, I would see that to get one period of this function that passes the vertical line test and also passes the horizontal line test, I could just graph one standard period of cotangent. And cotangent has asymptotes at 0 and pi. So if you take the graph of this cotangent and you think of it in terms of the unit circle, you start at 0, you go to pi over 2, that puts you in quadrant 1. That is where cotangent is going to give you positive answers. And if you looked in quadrant 2, that's where cotangent will give you negative answers. Now, once again, I could go around this circle as many times as I needed to, but to make something invertible, it's got to pass the horizontal line test. So we never extend this infinitely. We never extend it negatively infinitely. We only look at one period of the function. Then it's going to pass this test. Now, what does that mean? I'm going to do something very similar to this one. They're going to say y equals cotangent inverse of -1. So here's my job. I would take the cotangent of this side of the equation, and I would take the cotangent of this side of the problem. Over here, the statement just says, what is the cotangent of some angle y that I do not know? It equals, well, this would be a composite, so everything cancels. I get -1. And then I say to myself, well, wait a minute. For a come on, there we go. For a cotangent, if the answer's negative, I'm supposed to look over here in quadrant 2. So you only look in the quadrant you're supposed to. So here's the angle they're talking about. The cotangent of that is supposed to be -1. So I do adjacent over opposite, because that's cotangent. But this would make this guy a -1, and that would make this guy a rad 2. And I go, wait a minute. What is this angle? Whoops, sorry, I shouldn't have put the y there. What is this angle that would generate this reference triangle? And, well, this guy right here would be a pi over 4 angle. But that's not the answer you're going to find in the back of the book. Pi over 4 angle would put you in quadrant 1, so they want you to give them this. Oh, gosh, I'm trying to squeeze it in there. Y equals 3 pi fourths would put you in that spot. So let's just do some practice problems. Realize that I only put two functions here for examples. I only put cotangent and tangent, but you can partition off any graph to make this work. So here we go. I want you guys to do the mixed practice problems on page 258, 13 to 47 odd. I'm going to do some of the evens for examples. I'm going to show you, like for example, problem number 14. It says y equals sine inverse -1. Now I think of this as I'm supposed to take the sine of this side. I take the sine of the other side, which means I'm composing that. And over here, that means this stuff yields -1. And then I think to myself, sine of some angle I don't know equals -1. Well, if I try to draw a reference triangle, it's not going to help me in this one, because where does sine equal -1? Well, think of the sine graph. They have a sine graph going, goes like this, but that's going to give me 1 right there. That's going to give me 1. Where does that occur? At pi over 2. Well, I don't want 1. I want -1. But we don't look here. We know that it's going to be -1 here. We go, oh, 3 pi halves. That's the answer they want. If we do it that way, we would not have a invertible function because it wouldn't cross the horizontal line test. So I say to myself, man, that's not where I look. What does it say on the chart on page 253? If you want to find an answer for a sine graph, you're supposed to look between negative pi halves and regular pi halves. That's where you're supposed to look for a sine answer. So, where do we look for sine answers? In either quadrant 1 or quadrant 4. That's what the chart is trying to tell me. Since the answer is negative, I'm going to say, oh, that's the answer they want for number 14. Now, I went through pretty much a little bit of concept there, but the actual answer, draw the picture they want. So for sine, I just look right here. That's where I partition this thing off. And that would be the same as looking in a quadrant 4 situation. That'd be the same as looking for a quadrant 1 situation. In quadrant 1, sine's going to be positive. In quadrant 4, it's going to be negative. Now, let me kind of get to this guy because I haven't mentioned this yet. But number 16, I'm doing evens, says this. Y equals arc cosine of -1. What the heck is this? Well, this just means cosine inverse. When math geeks make up math, they sometimes use different phrasing or symbols or whatever. Arc cosine means the same thing as saying cosine inverse. It means the exact same thing. This was invented because they didn't want to have a lot of negative exponents and things to mess with your mind. So if you ever see the word arcsine, arctan, arccosine, whatever, it just means inverse. So let's rewrite this. So it looks like this in the book. This is what it looks like in the book. I'm going to say y equals cosine inverse -1. Then I'm going to do this to both sides. I'm going to take the cosine of this. I'm going to take the cosine of that. If I take the cosine of this side, I get -1. So on this side, I'm saying, what is the cosine of y? What is that angle y? I don't know. But I know that cosine, when I take a look at its graph, it's infinite in all directions. But for cosine, what does it say on page 253? It says, for a cosine graph, Oh my gosh, quit doing that. If I partition it between 0 and pi, I will get all the information I need from it. So between 0 and, what would this guy be right here? That guy would be pi over 2. So between 0 and pi over 2, that puts me in quadrant 1. Between pi over 2 and pi, that puts me in quadrant 2. So for a cosine graph, we only look in quadrant 1 or 2. Hey, right here at this location, cosine is equal to -1. So what is the missing angle they want me to fill in? They want me to say y equals pi. That's what they want me to say. So let's take a look at another one. I'm picking one at random here that says, okay, number 20, y equals tangent inverse of -1. And they're picking on -1 right now, but it doesn't mean my answer for -1 is going to be pi over 2 or pi or whatever. No, I would take the tangent of both sides. Tangent of y equals tangent of tangent inverse of -1. Over here I get -1. Here I get a statement that says tangent of y equals that. So what is this angle? Well, think about it. If you were to look at your tangent graph, whoops, okay, it stopped. If you were to look at your tangent graph, you're only supposed to look between these locations. And we would go like this. Well, the tangent, when does it equal -1? Well, if you remember from your graph, that's at -pi/4. Boom, that's where that would happen. But for some functions, you'll need to draw the graph like I did here for sine and cosine. For some functions, you want to do that. And for sometimes, you want to do this, where you just draw yourself a coordinate system and say, hey, tangent, where is it negative? I look in quadrant 1 or I look in quadrant 4. You draw yourself a reference triangle. And you say, hey, where would it be -1? Well, opposite over adjacent. So what do they want me to come up with? Hey, that would be a -pi/4 angle. Same thing, -pi/4. Whether I think of it this way or this way, I still get the same answer. Now, let's look at one where they give me a little bit different looking information. So I'm making the one up that says y equals arc sine of rad 2 over 2. Arc sine of rad 2 over 2. Now this is the same as saying y equals sine inverse rad 2 over 2. I could take the sine of both sides, sine of that, sine of that. I get sine of some angle y that I don't know is equal to rad 2 over 2. Now this does not look like something I want to draw a modified sine graph for. This does not look like it's going to help me, this strategy. So guess what? That's not the right strategy to use on this one. This would be definitely when I go, hey, I want to draw a reference triangle for this thing. And if it's rad 2 over 2 for sine, I am supposed to look, sine if I'm using it as a noun, in quadrant 1 or quadrant 4. My answer here, this rad 2 over 2, is positive, so this is where I'd want to draw this reference triangle. Now, this is the angle they want me to find. Now, rad 2 over 2, we don't have, if I write it like opposite over hypotenuse, it looks kind of weird because I don't have that in my bow tie. I don't have anything that looks like this. you can use Pythagorean theorem, you can figure it out, but this is a concept. Sometimes we do something called rationalizing the numerator. What? If I do rad 2 times rad 2 on the top, I get 2. On the bottom, I have 2 rad 2, and then those cancel, so it's like, oh, I could do this instead. I could get rid of this stuff, and instead I could put opposite over hypotenuse, and then I'm in business. And I go, oh, I recognize that. That's going to be a pi fourths angle. So the odd problems in your book, you can check all your answers. So I'm not going to take a picture of my answer key or anything. But, you know, there we go. You're going to run into, oh, let's try this one. This is a good one. Number 24. Y equals, what do they tell me? Cosine inverse of negative 1/2. So what do? I do the cosine of this side. I do the cosine of this side. Whoops. Over here I get cosine of some angle y is equal to negative 1/2. So let me draw this out, because when I need to find the answer for a cosine and I get something like this, chances are I'm going to draw a reference triangle. Now, cosine is going to be positive in quadrant 1, but what's the other place I'm supposed to look? Look on their chart. If it's negative, I'm supposed to look in quadrant 2. So here we go. I draw some angle. This is the angle they're talking about. I don't know what that angle is, but it has a terminal side. I can make a right triangle out of it. And I would say use this as a reference angle. And we're going to say adjacent over hypotenuse. And then I go, oh, that's looking familiar. That would make that a rad 3. So this angle that we're using to refer to must be a 60-degree angle. It must be. So a 60-degree angle is the same as a pi thirds angle, but that's not the answer in the book. What do they want? They want what was the angle that you had to draw to generate that picture. So the answer they want is y equals 2 pi thirds. You can check all your answers for the odds in the back. So let's take a look at one that messes things up. All right? And you have to be on the lookout for these, because they don't broadcast them. They don't try to make it too obvious for you. So this one says y equals arc sine of negative rad 2. Now, I look at this one and I automatically know that this is no solution. I look at this and I go, I know this is no solution. But how do I know that? Well, let me show you, and then you'll know it too. I would start out the same way. I'd say sine of y equals. Now, if I did rewrite this as a sine inverse, I would still take the sine of it, which gets all that junk out of my way, and I get negative rad 2. And right then and there, I know I can't do anything about it. Sine of this angle, which I don't know. I don't know this angle, but it's going to result in the answer being negative 2. Where am I supposed to look for answers for sine? I either look in quadrant 1 or 4, or I think of what the graph looks like. And if I think about the graph looking like this, remember the lowest value that will come out of this is negative 1. The highest value that will come out of this is positive 1. If you grab your calculator and you punch it in, this value is going to be negative 1.414, blah, 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 blah. Sine will never go below negative 1. You can't take this angle. Sine of what angle gives you nothing? There isn't one. So when you check your work in the back of the book, you'll find some of them it'll say the answer does not exist. Well, that's because this is a nonsense question. They're asking you something that cannot be answered. It's impossible. All right, so seeing as this sucker's impossible, I'm not going to waste any more time. But I am going to go through a couple more, because you're like, why? I think I get it now. Well, whether you get it or not, I'm going to do a couple more, because what about this guy? Y equals, what is it? Where is it? Cosecant inverse of rad 2. Cosecant inverse of rad 2. We haven't done cosecant yet. Can we? Sure. We'd go cosecant y equals, and if I did cosecant of cosecant inverse rad 2, then I'm going to get not cosine, cosecant y equals rad 2. And then I say to myself, man, my brain does not think in terms of cosecant. That's okay. If I want to, I can think of it as the reciprocal function. I could say sine of y equals 1 over rad 2. My brain is all good with sine. And if you look in the chart on page 253, you'll notice what's good for sine is good for cosecant. So which quadrant should I be looking in? I should be looking in quadrant 1. So if I want to answer this question, what I did is I converted cosecant into sine. I said, here's the angle y they're talking about, opposite over hypotenuse, and then I go, dang, that's familiar. Angle y must be a pi-fourths angle. Or, be careful. In the book, some of the problems, they're going to ask you to use radians, and some of the problems are going to ask you to use degrees. So just for kicks, if they ask me this, I would say 45 degrees. Or if they ask for radians, I would say pi over 4 radians. So what are we doing? We're using our bow tie information to work backwards. Up to this point, they have given us stuff like find the secant of pi. Now they're saying, here's the concept, work backwards to get the angle. So we're working backwards to get the angle. And remember, some of these answers are going to be impossible. And if they are, you just don't do them. But let's do one more with a funky function. And then you guys practice, unless you're like, I'm over it, I got it. Okay, hang on. Here's the one I was thinking of. Problem number 32. That's an even. It says y equals secant inverse negative rad 2. That's what it says in the book. So I would start off, I'd say secant y, secant this. I'd get the secant of some angle y that I don't know equals negative rad 2. And my brain says, I don't think in terms of secant, but I do think in terms of cosine, and I could say cosine of y equals the reciprocal of this thing. Now, you'll start getting used to this. This numerical value over here, if it's a 1, I'm going to think of the cosine graph to answer it. If it's a negative 1, I'm going to think of the cosine graph. If it's 0, I'm going to think of the cosine. But if it's one of these guys with my rads and it looks flavorful like that, this is when I'm going to draw my coordinate system. So sometimes we use the graph of the function to figure out the answer, and sometimes we draw ourselves a reference triangle to figure out the answer. Now here's another thing. Since I'm talking about a secant, I'm going to use cosine, but I take the reciprocal. So I'm supposed to look in quadrant 1 or 2 for this. So this is the angle they want me to find. I'm drawing a reference triangle to help me do it. And then this guy right here, that's the dude they want me to use as my reference angle. Now in the book, what they do for that is they'll do this. They'll call this guy y prime. They put a, you don't have to do that for me. It doesn't matter to me. But that's what they'll do in the book. If you're like, I need to look an example for this. So I look in the book for the example. They'll call this the angle you're looking for, and they'll call this guy y. This is pronounced y prime. Not Amazon Prime, y prime. So if they do that to you, that's what they're talking about. You don't have to worry about it. I can label it. I could say adjacent over hypotenuse. But wait, it's a negative. I could put the negative right there because it would make sense. Adjacent over hypotenuse. And then I'd say, oh, well, this must be a 1. That makes this a 45-degree angle in here. Or the angle they're actually looking for then would be a 135-degree angle. Or, if they wrote it in radians, 3 pi-4 angle. So just be on the lookout. Some of the questions it'll say write your answers in degrees. Some will say write them in radians.